All right, we'll be talking a little bit about an architecture that we're doing, but this is actually less about the product and more about something that we think is pretty important in terms of understanding replatforming the edge of the enterprise, especially in the age of cloud. So we are talking about cloud killed the firewall. So my name is Dan Backman. I work in technical marketing here at Skyport Systems. This is Michael Beesley, our CTO.
Good morning, folks. Thank you for joining us.
So the title here is, we're talking specifically about firewalls, and this is going to be a pretty technical discussion. We're going to get into some detail on some things that we think are pretty important about actually how you enforce policy at the edge of the network. But I think the more important title of this is, how can you really enable cloud and respect yourself in the morning? Because that's really what the big question here is. This is more about hybrid cloud than it is just about firewall technology. So before we dive into this, we need to have a little family discussion. So nobody knows how to drive you completely nuts like your family. And in every IT organization, you have a bit of a family. You've got your network folks, so just all cards on the table. I'm a network guy. I've been in the industry about 20 years. Michael's looking at me like newbie.
Yeah, exactly. I'm also have a networking background of about 30 years.
And Michael's modest. He's not telling you. He's actually one of the people who architected some of the key routers over at Cisco. So we've been in this for a bit. But so networking people are kind of special. And I say this as a networking person. So one of the people who runs our operations is a systems guy now, but he started off in networking. And he actually talks about network guys as packet Nazis. And he's kind of not wrong. You have to be a little bit special to be a networking person. So just all cards on the table. I'm a networking person. Michael's a networking person. We're going to talk about this in a little bit of a context from networking, but I think you'll understand why we're talking about this as a firewall. It's actually worse. I am a networking person, but I've been on the vendor side. So yeah, we've all committed sins in our career. I was the asshole that told your CIO that MPLS in the enterprise was a good idea. But don't hold that against me. I'm going to atone for that later. But you know what? Everybody in the organization is trying to solve a pretty tough problem with a pretty tough set of constraints. So if you work in networking, you kind of know what some of these constraints are. But we're not the only ones who are kind of creating pain for everybody. There's systems folks out there too. And systems folks actually get a little bit of the worst of all worlds. They're the ones who are basically forced to make everything work. The only problem is they do things that tend to drive the rest of us nuts. So I'm a networking person, and vMotion is awesome, but that really tied the network in knots trying to make that work. So you're starting to see a little bit why there's some family dysfunction. Everybody needs to kind of work together. And by the way, the whole fiber channel over Ethernet thing, that was the worst crime against networking since Apple Talk. That was awful. But it's not the systems guys. They're working with constraints. A lot of the things that they have to do are there because of the way the applications you have to support. This is a security convention. We need to talk to security. Personally, I actually think the security guys have the hardest job in the IT org. It's all of the responsibility and none of the control. That's a tough spot to be in. But these are also the guys that tell us to install all the agents on your machines in order for security. And then they're also the ones that tell you to install lots and lots of extra boxes all over the network to try to keep us magically secure. We'll get back to that a little bit. They're not the only ones causing strife, though. All right, now you got the folks who actually are responsible for the applications. And this is where it starts getting tough. There's a lot of things that we have to do to make the apps work, and everybody starts jumping through knots. And by the way, if you all haven't started playing with containers, just wait. This is going to be fun. All the assumptions you had about how your IT org works, they're going to change. And we can't poke fun at the family without poking fun at mom and dad, the management. So you've got the CIOs, the CISOs, and they have a pretty tough spot because they're the ones who are actually trying to keep this family together. But at the same time, we all have stories about why they drive us a little nuts. So we got to ask a little question. Why do we fight so much, Michael? Why do we fight?
It's an interesting question. I think there's a couple of fundamental reasons why each of those organizations end up with tension and fighting and maybe a non-ideal outcome. I think the first is architectural. All those teams are working with an architecture in a standard enterprise that is quite out of date and antiquated, given what is happening in modern enterprises, given the fact that we are now hybrid and very mobile, We have an architecture that was built for a previous era and generation, and it is not suited to that hybrid enterprise, and it is not suited to having mobile clients. I think that's the first reason why we fight. The second is that by nature, each group wants to stay in its silo, and vendors have crafted sets of tools that really encourage that silo mentality. The security person is specifying the firewall, the networking person is installing it and wants to manage it all by themselves without taking into account what's happening amongst the application teams, what's happening with containers, what's happening at virtualization, and what's happening in the line of business and application teams within the enterprise. So I think they're the two fundamental reasons why we're fighting across organization with a result that is non-ideal for an enterprise in the modern world.
So we're going to get into some pretty gory details about why we think things have changed and why we actually need to change how some of these controls work. But before we do that, let's look at something specific. What does every family fight about? There's usually that one crazy uncle in the attic, the one with the National Geographics. It's the DMZ. Like, who here really wants to work in the DMZ? I'm guessing nobody. It's generally the most broken part of the network, and it's the most broken part of the enterprise. So we all fight about something. This is where we fight first, usually, in almost every place that we look at. I mean, for God's sakes, there's probably still Sun servers in this thing, right? This is a mess, and it's actually a really good thing to look at how we can clean up this mess. And there's a couple things that have happened that have forced us to do this. But first, why is it a mess? It's not just that we can't all get along. There's a whole bunch of rules we have to follow that are also written by people who necessarily aren't part of the family. This is creating a lot of the mess too. But let's talk about sort of why this is so hard. This is something that exists to literally protect you from the outside world. But two things have happened since this was architected 20 years ago?
That's exactly right. The DMZ really hasn't changed much in a decade or two.
We see two things that are basically making this untenable. DevOps is happening, which is your CIO basically saying, hey, app devs, go do everybody's job and make things happen faster. And also, the next thing is cloud happened. And we're going to talk a lot about that because cloud really changed the rules about how this works. Now let's take a look at some of the assumptions that firewalls and all these things were built. So we may all fight, but there's reasons we have to fight that are sometimes coming from outside. So let's talk about how we got here. Why did we build this DMZ the way we originally did, Michael?
Well, the original abstraction for an enterprise was a walled garden or a walled castle. That's how it used to be, where all applications were delivered from the enterprise data center. All clients were by and large on the enterprise network. There were very few connections to the outside. There were very few pinholes through the firewall, and hence the DMZ was a reasonable approach to securing it. And it was mainly to secure user activity and much less to secure machine-to-machine or app-to-app activity.
And it was really there to keep the marauding hordes out too, right? That's why we put the firewall here.
That's exactly right.
All right, well, we need to ask some questions about this. So what is that thing actually doing? So many things have changed. What is your firewall actually doing at the edge of your network? Michael, what's a cargo cult?
To be honest, Dan, up until this week, I did not know what it was. But why don't you give us a summary of what it is?
I won't read the Wikipedia page, but it's like a World War II thing where people started to build these fake airfields, hoping that the people fighting the wars would bring in cargo. And it's actually kind of the embodiment of you do something, but you don't know why you do it. And now it's been appropriated in technology. So think of all the things that you do it just because. And I'm willing to bet you that a lot of the reasons these firewalls are still there, when we talk about why we have some limitations, really get back to you have them there because who's the guy that's going to say, pull them out because they're not doing anything useful anymore. So let's talk about specifically why cloud broke the firewall. So appreciate the family chat. We think this is important because there's an important thing going on here, right? There is something broken, but it's more than just technology. Now, technology did change. So there's three things that are different now that cloud happened. First, IP addresses are meaningless. Your whole concept of what that firewall is doing and controlling individual IP ranges has literally no meaning anymore. Cloud broke that. and the way your internal organization works, how DevOps processes, how virtualization work, have fundamentally broken that. The other problem is that pretty much everything going out to the outside world is encrypted. What is it really looking at? And yeah, there are ways that you can try to peek inside, but things get pretty complicated when you start doing that. And it's all web traffic. So what exactly is that very expensive box doing at the edge of the network that's actually protecting you from the marauding hordes? And by the way, let's not cover the obvious, which is where is inside versus outside anymore? If you're hybrid cloud, like where is your perimeter? So let's talk a little bit more about what we're actually controlling. So if I go to you, Michael, let's say you're the guy who didn't run fast enough and needs to run the edge firewall policy, and I tell you, you need to protect us from the bad people outside, but still allow access to cloud. What do you do? Like, how do you allow access to cloud? What are you actually opening yourself up for?
Yeah, that's a really hard problem. In the end, what I do is cheat. I put in a bunch of rules that look sensible, and then at the bottom I put in a default allow all rule, because things like AWS and Azure represent such vast swaths of the address space, and so many services are either there and or fronted by other CDN services, I can't possibly write a tight policy with regard to allowing the enterprise access specific services on the internet and not everything else. It's a very, very difficult challenge.
So right now, let's actually look at what you're allowing access to. There's a few people, like the big boys. If you're allowing access to Google, Facebook, some of the really big organizations, usually the web scale folks, they have their own dedicated address ranges. They're now starting to offer more services where they're actually fronting more and more services. But you at least have a prayer of doing things like whitelisting IP ranges for Google, because you could actually read the advertisements out of BGP. But how much of the internet is now running outside of or inside of Amazon? It could be like all of Netflix is running inside of Amazon. If you guys use Slack, that's running in Amazon. If you use things like Reddit. And for all the stuff that isn't actually sitting in Amazon's address space, pretty much every other web service that you're using is sitting behind a web front-end service. This is what people like Cloudflare and Fastly do, and things like Akamai and CDNs do. So if you're actually trying to control access, how do you even do this? And by the way, about half the stuff behind these front ends are actually running in Amazon behind the scenes anyway. What are you actually controlling? What are you actually allowing access to? This is why you care. It's not just about the web services that you have to allow access to. If you open yourself up to places like Amazon or some of the front-end services, it's everybody else running behind those. We already have documented cases of botnets. The Mirai C2 servers are running in Amazon. If you open yourself up to Amazon, it's literally pretty much the entire internet. In fact, if you look at the numbers, I pulled this last week. They published their public address range. That's the dump of them right there. Last week it was 881 prefixes. I'm a network guy, so I think in prefixes, but that's about 54 million IP addresses. It's about 1% of the entire internet, just in address space alone, just inside of AWS, by the way. 1% doesn't sound like a lot, but literally 1% of the global address space, and I cheated, I included Class D and Class E in there. That's how much address space they represent. If you open yourself up to Amazon, you are basically writing a policy that says, allow any. Now the other fun part, it's all encrypted. So what are we realistically trying to do with this traffic when you're passing it through a layer that's adding more security? If you want to actually start looking inside of this, you have to pop TLS. It is web, you have to now man in the middle TLS. And in general, this is where you start running into some significant challenges. I mean, if you start talking about cracking TLS, like what is that, just in terms of deploying this, what does it do to your traffic when you start to man in the middle?
Yes, it's very, very difficult. I mean, you've got all the certificate management, you've got all the traffic management, and you've got to make sure that you do it correctly, because cracking it open and re-encrypting it is itself a vulnerability and can open up another threat surface.
And let's not forget the last fact. Managing policy is painful. So one of the reasons we bring up sort of where we came from. So I came from the networking side. I've managed these firewalls. I've worked with customers that built out huge firewalls. Here's your problem. This is a simple policy. This is the policy that allows traffic out to Cloudflare. And this is the kind of policy you have to build. If you really squint, you can actually see that's more or less legit pseudocode for policy. But here's what you actually want. When you start having applications that reach out to cloud, what you actually want is policy that says, I have an API server, allow access to that API server in Salesforce, and now my gateway should only be talking to that. And by the way, it's also talking inside as well. So don't forget, it's not just one place that you're doing the policy, it's every hop along the way that passes through a policy enforcement point. You're managing this much policy. So there's actually a bigger problem. So let's actually take a look at this. Policy management, the reason we're talking about this is painful. This is one of the reasons why we fight. Why does nobody want to fix the DMZ? Because it means somebody's got to go through and rationalize all that policy that's there. Can you look at your core firewall and tell me what all those rules are actually doing right now? Probably not. Even in the best run environments, it's really hard to track down. But now let's talk about some interesting problems that you run into every day. We're going to be talking about AD security in the next session, but let's actually look at something really simple. One of the most important things you can do to protect yourself is to apply regular updates and patches. How do you whitelist Windows Update? Have you looked at actually doing that? So I posed this question to some folks from Microsoft Consulting, and they came back and said, yeah, that's actually kind of tough. And here's why. First, those are a list of URLs that you have to whitelist to make Windows Update work. But here's the problem. Let's follow the rabbit hole and figure out what those URLs actually do. If you whitelist Windows Update, first, we'll just pick one. We'll pick update.microsoft.com. Well, guess what? That's actually a pointer to a content distribution network. Microsoft isn't hosting these all themselves. They're farming that out. And by the way, it's more than just one. And once you start walking through the trail, you end up ultimately with an IP address that is effectively random. If you try to do IP-based whitelisting, even for something as simple as Windows Update, you basically have to functionally open yourself up to the entire internet. So this is a tough problem to solve. This is why people put full proxies in their environment, to try to get this much context on web traffic. Now let's look at the next problem. Let's actually look at all the stuff that's sitting behind these web front-end layers. I'm going to pick on DigitalOcean just because I happen to know that they're one of the people that are running inside of Cloudflare. So if you're talking to DigitalOcean, even something as simple as their website, you're actually going to their front-end layer, which is distributed across the entire world. And they're actually serving up the web front-end layer, and they do origin traffic back to the customer. Now, because you're speaking to a common layer, you're sharing addresses with everybody else that's on that service. How do you know that you're actually going where you want to go? The only way you could do this is to actually start looking at the TLS session yourself. And you can look at things like server name identifiers to actually understand where is this going, and how do you now build policy to go just to DigitalOcean and not some of these other sites. And one of the other reasons to bring this up is guess who else is there? It could be potentially anybody who's actually running behind that front-end layer. So right about now, if I put myself in sort of vendor land, I would start thinking about if I was one of the firewall vendors, I would have an answer to everything we talked about, right?
You would. And the question is whether those answers are true and whether they're practically executable in a normal enterprise. And certainly a next generation firewall is an amazing machine with amazing sets of abilities. I would say the couple of key weaknesses. The first is the concept of zoning on the enterprise side, and those zones represented in the firewall. I'm going to argue with a hybrid enterprise, coarse-grained zoning is not effective. The firewall or the security policy needs much more context with regard to source and destination. It's not that update services are good or bad. It is that there is a very small set of machines or VMs in the enterprise that should be going to those update services. And no other machine should be going there. That is the challenge, and firewalls are very, very difficult to manage and to configure with regard to source and source context. You end up basically with a zone with a single virtual machine in it, which is just not practical with a modern firewall and with modern virtualization. I would say the other obvious challenge with the firewall is that an awful lot of your enterprise traffic is no longer going through your enterprise firewall. In particular, on the client side, I mean, the clients spend more than half of the time off the network, so they can't possibly actually go through the firewall regardless of how it's actually configured.
All right, so this is where we're going to get gory. We're going to dive into something about context. And I'll give you a quick analogy about context. Think about what happened when you flew here. You went through a TSA checkpoint. And what that's effectively doing is proving that you are allowed to be in the terminal. But let's say that they wanted to implement a rule that said, I want to know who here is flying to Nairobi. Now, I live in San Francisco, so whenever I go through SFO, if I go in the United terminal, I know for a fact that probably 80% of the people in that terminal are getting on a flight that's going to Chicago, Houston, Dulles, Denver, one of the other hubs. If they're going to try to influence policy based on where people are actually going, all they can see is your first hop ticket. They don't know where you're actually going. That's an example of context. Let's see how that applies when we start looking at how to do policy. So I'm going to pick on actually something really simple. So one of the things that we're going to call out is if we're going to make policy simple, we have to make it dynamic. You have to be able to address things by name. In this case, it means things like DNS. It matters both inside and outside. And you know what? If you look at any one of these next generation firewalls, you can do this. You can base policy based on DNS FQDNs. And the way it works is you type in the domain name and the firewall looks up the DNS entry and then plumbs IP policy, right? Seems perfectly legit. If you think about how would I make that work, that's exactly how you would make it work. So let's actually look at a really simple example. I picked something here that actually demonstrates why context will fail with this policy. Here, I have a Linux box, and it's going to speak NTP. The other fun thing here is this is a non-web protocol, and it still applies. So it's going to speak NTP. I'm going to use one of the public pool servers. And when I made this policy in the firewall, I'm not sure if you can see it here, but you came up with 4 IPs. And the trick here is every time you query, it's going to give you a different list of IP addresses. In fact, when I actually ran that executable on the actual server on the inside, because this is effectively a round-robin DNS, it got a different answer. And guess what? It fails. You built the right policy, you built the right name, you went to the right place, but because DNS is actually handing out different information to different clients, you're implementing policy somewhere with the wrong context. You don't actually see the same view of the namespace that your client does. This is an example of why context matters and why things like this can break. But let's look at more about context. Now we're going to expand this a little bit. What we're really talking about is if cloud killed the firewall, one of the things that happened is that applications behave differently now. The things that are actually reaching out and talking to cloud services are usually some form of gateway. And I'm going to look at a couple examples here. So one, this is probably a pretty common thing. If you use Salesforce, like probably what, half of the companies out there right now?
Yes, indeed.
And maybe you have an internal ERP management system on the inside, maybe we'll call that SAP. You've got to connect these things together. So when the sales guys enter their order, you're automatically creating forecasts and plumbing to build widgets, right? How do you do that? How do you connect your internal system to something like Salesforce? 9 times out of 10, there's code that is running in a gateway whose purpose in life is to reach out to Salesforce, log into Salesforce, grab data, and then reach into your internal system and do something with that. Another good example where you're already doing this is single sign-on. If you guys are offering single sign-on for web applications, you have a cloud service, we'll pick on somebody like Ping or Okta or ADFS in the cloud, where you now have a cloud service which now needs to reach in and talk to your Active Directory domain controller. Let's talk about critical assets for a second, right? Well, how do you do that? Now you have something that lives kind of both inside and outside of your organization. So why does context matter here? Why do we care about something as abstract as context? Because think of what you're trying to do when you actually build policy to control these things. The first thing you're trying to do is...
You're exactly right. It depends who is talking to what. That is the key information that says the conversation should happen or not happen. And I mean, we used 2 examples here. This is the fundamental shift with regard to the hybrid enterprise. This is the difference between today's enterprise and the old walled garden or walled city that we used to have. Now we have application mashups that spew across our enterprise perimeter. Parts of the application are in-house in our data centers, and parts of the application are out in the cloud. And how do you set policy, provide security and visibility and agility when you have that kind of architecture?
We're going to talk more about these cloud gateways, but let's look at what we're actually trying to do. If you have something as critical as talking to your Salesforce instance in your ERP system, You need to protect this. You need to lock down that access. So what are you actually trying to prevent? Well, first of all, maybe that's the only thing inside your data center that should actually be talking to Salesforce, right? That's an obvious policy thing. It's least privilege. That's the only thing that should be authorized to reach out. So the first thing you're trying to do is prevent unauthorized entities inside your data center from reaching out. The next thing you're also starting to look at is how do you know that that agent is actually talking to the right ERP system? One of the really sophisticated attacks that happens internally in infrastructures now is actually starting to masquerade services and create man-in-the-middles inside of that infrastructure. This is how you can get completely owned. There's some great SSH-based attacks where they work by actually poisoning DNS and creating a fake man-in-the-middle and relying on the fact that most people, when they see the SSH key verification fail, they just hit keygen and delete it and redo it. That's how things break, and that's how people will actually attack these applications. So what you need is the proper context to know that that gateway is talking to who you actually intended to talk to on the outside. If we talk about things like domain fronting, that's why you have to have effective policy that's cloud aware, and why you can't just open it up to things like Amazon or Cloudflare or Fastly. And then on the inside, how do you make sure that that critical control point is actually talking to who you intended to talk to? What happens if you spoof the SRV records in DNS so that now your single sign-on gateway is talking to a fake domain controller and not the real one? That's one of the ways you could potentially try to compromise authentication in the system. So this is the type of policy you need to think about at the edge. And if you start looking at how things are traditionally done based on the perimeter, this is really hard. How do you figure out spoofing when that thing is a couple hops away from you? You basically have to trust the network. And the whole point of this level of security is we're moving to a point where you should never have to trust the network, and you can actually tie policy context directly to the thing you're trying to control. Now there's also pain. We started this off by talking about why we don't always get along. Nobody likes to take out the trash in the family, right?
That's exactly right.
Who likes to clean up and manage the policy? If you start looking at the level of policy that we're talking about in order to do this complex policy for all these gateways, you're at thousands of lines of config very quickly. And this is why there's scale problems. So I worked at a previous networking vendor, and we actually had a test case of how far can you scale firewall policy. 92,000 lines. It was an actual customer instance. No human being can understand what those 92,000 lines of config do. And the problem is this gets worse and worse and worse, because now show me an app inside your data center that doesn't reach out to cloud. Probably half of your data center. Run this as a test, by the way, probably not in production, but as a mental exercise. Think of what happens in your data center when you would shut down internet access. How many of your applications would break? So what does your policy really look like at the perimeter? This is what it's starting to look at in a lot of the companies we deal with, and cloud makes this worse. Because now all that policy that you're trying to do is not actually even aware of cloud and doesn't have the right context to work. So one of the main things here, this is not just about security. This is about solving real pain. And managing the policy at the edge of the network is one of the most painful things out there. I know it. I came from the network side. You built the boxes that do this stuff.
That's right. It is very, very difficult. It's also very, very difficult to A/B test a new firewall configuration. I mean, every time we get to type commit, it is a leap of faith, both in terms of operational continuity as well as actual security posture. So it's very difficult.
So this is what we're really talking about here. How do you fix this? Well, first, if you want the policy to be effective, it's literally happening in the wrong place with the wrong context. We have to fix this. Now, the important thing that we're going to get to here is why this really matters. So now let's talk about what really happens when things get deployed to cloud. Everything we've talked about now is pretty technical, but the biggest pain you're probably dealing with probably looks something like this. Let's say you're an application owner, and you want to turn up this new app, and it's got to go talk to that cloud service. What happens? Well, you're the app owner, you call up the IT guys, and what normally happens when you call up IT? What do you have to do?
Yeah, you want configuration change made, and you need it to be made very, very quickly. And if it can't be made in time, you want an exception.
Yeah, how long does that take? You're gonna allow something to go from your data center out to cloud. Okay, it's got to go through security review, it's got to go through change management. If you're gonna make a policy change in something with 10,000 lines of policy, you need to make sure you don't break anything, because if you get it wrong, you're either gonna open up that policy or you're gonna shut down and break another application. So you protect stupid with change control. It happens in every organization. So the answer back to this app owner, more often than not, is no problem, we can get it done for you in what, a week? That's pretty good in a big organization, maybe 2. Now, by the way, let's say they asked to put this into DMZ, really where it belongs. How long is that gonna take?
Yeah, that's months.
Yeah. So what really happens? If you're that app owner, you hear back, open a trouble ticket and we'll get it done in a week. What do? Well, you call up the CISO and you basically say, if I don't get this app delivered, I'm gonna miss my deadline and the business is gonna suffer. And then what happens?
Then you get the exception.
Right. So the bigger problem here is shadow IT. So because we've made it hard to put these things in the right place with the right policy, and we've made it hard to manage that policy, people go around things that are hard because they got their own job to do too. And this is part of the family dysfunction that we're seeing. What really happens, these things that should be in the DMZ aren't in the DMZ. They're running in the middle of your data center, and every single one of them has an exception through that firewall that says you're allowed to go to cloud. And because you can't actually say what cloud instance you're going to, it basically says from this IP, any out, and maybe make sure it's web. And you get VPNs everywhere. And here's the problem. You're Swiss cheese if you have a bunch of IPsec tunnels terminating in the heart of your data center from somewhere else that are encrypted with no visibility. Because these IPsec tunnels aren't terminating in the firewall like you would expect them to. They're running in a process in a VM somewhere. This is the biggest challenge that we see, is that because it's so hard to do policy right, people lose control. And you've got a mismatch. The more DevOps you do, the quicker you can roll out an app. You can turn up a cloud instance in minutes, but if it takes you weeks to update policy, everybody's gonna go around you. So what do we do, Michael? What's the box we build as a vendor that fixes this problem?
Yeah, I mean, fundamentally, the solution and the architectural adjustment is around the compute infrastructure that you use for these edge applications, for the applications that speak out and speak back in. The challenge is providing policy, visibility, and security to those virtual machines. The answer is not more networking-based equipment and more networking technology for all the reasons we just discussed.
So think about what Michael just told you. We're a bunch of we're self-professed network people. We even got the scumbag vendor hat on. And we just told you that there is no box you can put in the network that will fix this. The problem is, if you're trying to do this policy in the middle of the network, networking got one thing right. It's zero trust. You're never trusting the thing that you're trying to protect to police itself. That works, that makes sense. But the problem is, if you put that in the middle of the network, it'll never have the right context to understand what that app is actually doing. The problem here is this is an application problem, and you've got tons of these. Here's a few examples. Like, if we look at what changed over the last few years in your data center, these things are popping up like weeds. Every new cloud service you have has a new gateway, and they're all talking out to cloud. And some of these are going to some random instance in Amazon. Some of these are going to a SaaS service, but they all are single-purpose things that have very, very limited scope. They're doing something important, but they should only be doing that. And it's almost impossible to provide effective policy. Why? Because they're not running where they should be. These should be in the DMZ, but the DMZ is at this point pretty unworkable. Nobody's gonna put it in the DMZ because it's gonna take longer to get in there and get it working than you have. So here's what we're talking about, is actually something conceptually not hard. What happens if we can give you a place to run these that's effective, that actually has cloud-aware security, that becomes something that the DMZ tried to be, which is now a safe zone for connecting to the outside world. They should be in the DMZ because remember that discussion, but now, if we can give you a place to put these, where it's actually less painful for your application owners to put them in here than it is to get that exception, this is how you implement effective security, because this is how you get people to stop going around the security controls. This is the solution, but it requires some hoops. So we're talking about a new architecture. That's why this is in a box. This is a new architecture. How would you talk to your CIO about this? Well, Michael, you're half CIO anyway. How would you talk to your CIO about this?
I mean, the main point, obviously, it enhances your security posture and visibility greatly, but from a CIO and even CEO perspective, what it really does is allow your hybrid enterprise to fully move at the speed of business, to give you back the agility. If you think about what's happened in your main data center and what's happened out in cloud, both those environments have become extremely agile, self-service environments. Your app teams, your line of business teams can do their work very quickly on the self-service portal in the main data center, as well as out in the public cloud, whether that be infrastructure as a service or signing up for SaaS services. The thing that is hurting from an agility point of view is actually the DMZ. It's actually the firewall and the network security controls that are slowing everything down. That's why so many teams just bypass. They either go shadow IT or they ask for an exception. So if it was me, how I would present this to the CIO and the CEO is it allows the enterprise to move at the speed of business, all the while enhancing security and visibility and giving you cloud-aware policy control for all the edge virtual machines that are talking out and talking back in.
So this is what this conceptually looks like. Think of what would happen. What would the right solution for this to be? So first, these gateways communicate with the outside world and the inside world. You need a place to put them, but where you put them needs to have effective policy both north and south. Now, the agility gap, the way you solve this is you make this as easy to use as cloud. So every time an application owner comes around and needs to spin up one of these apps, you give them the way that you can instantiate a swim lane effectively for each one of these apps. You host the app. It's generally a virtual machine today. You have to be able to host it as a VM. You have to basically build a software-defined DMZ around every single one of these VMs. Because the DMZ is actually tied to the VM, it actually has the right context. It actually sees the world and understands policy the same way the VM does. So you can actually create cloud policy that works. And it starts to scale up. And it's agile because this behaves and looks and smells more like a cloud service to your internal users than anything else. Self-service is what makes this work and what makes customers not go around you. So why has nobody talked about this yet? Like this contexting, you don't hear a lot about this. Why haven't we had this discussion yet? Like this is, I think the biggest thing is the biggest problem with existing network security stuff is that it doesn't have the right context to deal with cloud. But we're not the first ones who have come up with sort of a cloud security solution. What's the other thing that people talk about with cloud security?
I mean, certainly with regard to clients, it's how do your clients safely get to cloud? How do the clients get to SaaS services, whether the client be on your network or off your network? And that really has begotten the cloud access security broker market and technology, because you need the same policy controls and DLP policies and visibility for client traffic, regardless of where your client actually is, whether it be at an employee's home, whether it be in a Starbucks cafe, at a customer site, at a trade show, as well as being on your enterprise network. You need consistent policy and visibility with regard to the client traffic, and that really is the CASB market.
Yeah, and this is your Zscaler, SkyHigh, Netscope. There's a whole bunch of people that do this, but what makes that work is they figured out user context. You need policies to apply to a logical user. What it doesn't solve is the problem of machine to machine. What are you doing to actually apply policy to applications? Applications, you can whitelist, and you actually should whitelist them. You can't predict a user. That's why the CASB market is trying to solve a hard problem. It's great technology, but it's trying to solve how do you actually control an uncontrollable user. Machine to machine, these gateways have only one purpose in life. That gateway that connects Salesforce to your internal ERP system should only be doing that. If it's reaching out to Reddit, that's a problem. That's probably a C2 channel. That's why that stuff matters. So if you're going to build a solution for this, you have to have something that addresses all the things we talked about. You assume that this is application security. You have to wrap it around a VM because that's the packaging that these things run in. You need policy that works with cloud context, that actually understands applications sitting behind web front ends and running in Amazon. And it has to be self-service, and it's both policy and deployment and provisioning. So I'm going to skip forward a little bit here just because I want to make sure that we have a little bit of time to go through this, but let's actually go through the day in the life of what an architecture like this allows you to do. So now you're an app owner. You want to turn up one of these gateways. The first thing that you would want is something that makes that self-service. Have a way that they can take this VM and deploy it on their own without opening a ticket and having the virtualization team provision a VM for them, make this kind of behave like a cloud experience, because that's what makes them use it. But that's the first piece. They know where this thing is supposed to go. Why can't they set the policy? If you can actually now make this a per VM DMZ, two things happen. You can actually allow self-service policy. You can build guardrails on what that thing should be allowed to do. So you can still implement some adult supervision, but they know what cloud service they're using. They can manage that URL, so this way they're not relying on another team to do it. And now you look at, well, why would I possibly allow that? What's the worst thing that could happen? Well, you're going to screw up policy in one of two ways. You're either going to put the wrong thing in there, and you're going to break your application. But guess what? Once it's self-service, if you break your own app, you can fix it right away because you know immediately you're part of the closed loop. And second of all, the thing that most security people would worry about is what happens if they screw up and say allow any in? Here's the other difference. That's not a network connection. That's a VM. Even if you make a crazy policy that opens it up, the worst thing you've done is expose the surface of the VM. You're not creating a transit network connection like you are with a firewall. This is how you modernize security, and by making both of these things part of that same self-service process, this is how you make it agile. But the final piece that really makes this work is what's the thing that nobody has access to? Like, we network folks are guilty of lots of stuff, but the worst crime that the network folks have done to everybody else is they don't give them access to all the tools that they have, because the tools aren't really meant to do that. What does it take to get a view of what traffic looks like from one of your VMs if you own the application? That's not easy. The tools aren't usually there. Or if you want to get a packet dump to debug why something isn't working, how many hoops do you have to go through to get that? If you can add that visibility inside of the same architecture and now make that self-service too, now the app owner can deploy it immediately. They can build the policy. They can see whether the policy is working as intended. They can see whether that gateway is actually doing what they think it's doing. And if something's going wrong, they can actually debug it, visualize the traffic, even get a packet trace of what's going on in real time without having to call the network guys, which means that if you're the network guy, you don't get woken up at 3 in the morning for a trouble ticket that says turn on a packet dump. And now the app owner gets to solve their problem immediately because they're in control of all the pieces they need to be in control of. So where does this get you? Why are we talking about cloud killed the firewall and talking about all this other stuff? Because this is how you solve the biggest problem that our family is kind of dealing with, which has to do with policy. Michael, you said something pretty important about security at breakfast this morning. What was that? Whose job is security?
Yeah, I mean, that's one of the challenges. Obviously, from an org chart point of view, security is owned by the security team and maybe the networking infrastructure team, but really, security is everyone's job. That is the reality, that is the challenge, and until we behave that way, and until we use tools and architecture and infrastructure that allows security to be everyone's problem and everyone's mission, our adversary is going to continue to win because they win by dividing and conquering against us because they know our structure, they know our tools, and they know our tendency to drop into silos. So really, security is everyone's job.
So let's look at what security and policy looks like before and after. This is the world you probably live in now. You've probably got huge firewalls. You probably just bought a new one to go 40 gigabits. It's probably got 5,000 plus lines of config. That only works for traffic that's going through it, by the way. It's got a whole bunch of different zones. There's nothing inherently wrong with this. It's amazing technology, and you probably have lots of them. You probably have lots of layers of these things. But now the challenge is that first, it only works for north-south stuff. It doesn't protect anything on the inside, because the problem with having firewall or any type of network security is no matter where you put it, it's always in the wrong place. And the other question is simply scale. Like what happens when you move a VM? If you move a VM from one zone to another, guess what? You got to fix policy and you can break policy. If you build something where the policy is actually tied to a VM and moves with the VM first, a lot of your housekeeping work gets a lot simpler. The policy is simpler. Instead of having thousands of lines of config, it's 2 or 3. It's allow access to this cloud service, allow access to this internal resource, and maybe SSH in or web in. That's it. That's like 4 lines of policy, not 4,000. And finally, what you now get is 100% visibility and 100% east-west. And in the end, because you've now tied the network security, policy enforcement, and visibility to the workload, this scales linearly. This is how you actually build a 1 terabit hybrid cloud exchange. You don't do that by trying to scale up one box. You build a front-end layer for your environment that works the same way that a front-end layer would for one of the big web scale folks. It basically becomes a grid, and the security inspection scales up as you add gateways because it's part of compute. This is what we think the future of the perimeter looks like. So ultimately, what you now have is a place where you can securely host this stuff. And now, let's look at our family in this world. What does this look like? Why do we fight? We fight because we're in silos. If you're in a world where you have something like this, if you're an app owner, you can deploy it right away. And guess what? You can do your container thing, because now you have a place to put it where you can now rendezvous context with your container policy. By the way, containers means that you're going to instantiate ephemeral workloads at will constantly around your entire enterprise. Like any hope of trying to map that to firewall zones, good luck. But now you've actually got a place for them to put stuff where you can actually now rendezvous with the right policy. Network and security teams, you get to work on architecture instead of endless ticket management, because now things are self-service. You can allow people to debug problems themselves. If you're the infrastructure team that's maintaining compute, you now have a safe place to put things where it's hardened, where you can actually replace a lot of the complexity in probably the most horrible part of your environment, which is the stuff that touches the outside world. If you're a security guy, Michael, how do you feel about this?
You're very, very happy. You're sleeping happily. I mean, you've distributed the job of policy management to the bigger organization, to the app teams and the app owners, and you finally have effective policy and visibility around workloads that are reaching out and reaching back in, which is one of the big challenges today.
And this is what it looks like. This is an architecture. This is an architecture that you deploy. This replaces the concept of what you think of as a DMZ. This is something that's hardened. It's designed to run outside the firewall because this implements a security stack. It's something that has all the things you need to run these gateways, because these gateways are now the new way of getting into and out of your organization. It's not a network problem anymore. It's an application problem anymore. Think of that API gateway and where you put it. That's what goes in here. The connectors to SaaS, that's what goes here. So now you need something where you can deploy this. You can make this whole software-defined DMZ something that automatically gets built around a VM, and the rest of the pieces need to get out of the way. So you need to have something that gives you all the toolkit to make the work of housing virtualization, building security policy, and orchestrating that go away. Now, we're here to talk about an architecture, and we believe that this is a valid architecture regardless of how you build it or whose tools you build it out of. We think this is the future of what security looks like into and out of the edge of your enterprise. We are a vendor, we are guilty, we happen to make a product, but we didn't want to talk to you about that today. We want to talk to you about this architecture because we believe this is right regardless of who you build it from. We would love to have a discussion about how we can help build something like this, but I think that's a talk for another time. If you would like to have a further conversation about what this architecture looks like or how we can help you build it, please reach out to us at Skyport Systems. Michael, thank you, and thank you for joining us.